It's too large. Can you
Look
somewhere else? All right, so background while Paul is looking for the slides. Essentially, this is a subjective, a me statement. I've been in this industry for too long, and which means for, again, too long. Most of that time I didn't do any development because that's not what we do usually. Meaning I got out of being a developer Java 1.4 times. I don't know when that was, early 2000s something. And essentially one of the reasons why I stopped doing any work in that area back then is I was in a context, and I come across these contexts still all the time, where you have somebody writing enterprise software in Java, and it takes a week to even get the workspace to compile. I think that's gotten better, I hope, but the point is that's kind of where I said, sorry guys, but that's, that can't be it. Anyways, couple of years ago, 1 or 2, I was allowed to / able to try to become a developer again. But I wanted to do something interesting, new and useful, and that's why I started to learn Rust back then and use Rust. And as mentioned in the UPollimer project, so essentially the reason why we do have the headline, like the latest and I think quality-wise best implementations of our things in Rust is that I started like 2 years ago. And we had to rewrite everything that I did initially, but anyways, we did that too. And there's 2 main takeaways from me using Rust for a year, 1.5 years now. One of them is confidence. Like, you all know that's stupid and it used to be a bad statement, but if it compiles, I'm happy. Actually, if Rust code compiles, you still can have, structural, logical problems, but that's pretty much it. If it compiles, a lot of things that usually do go wrong in other contexts will not go wrong.
Context for this, we did a comparison with Exeter of Rust versus C. They had a little tools suite that they put together to do a comparison of checking tools for C. And they used it to compare all sorts of open source ones, but also some commercial ones as well. So we went through and went through their tests to identify 2/3 of the test cases for Rust wouldn't even compile. So it wasn't that you needed to catch them in a checker. They wouldn't compile at all. Another 25% you would have caught with panics at runtime. And Rust, you can actually set it up so that you can build it so that it won't panic. So that means 90% of the things that you are catching in the best of class, so that's beyond Minister, that's the best of these things, you're just getting for free with Rust.
So essentially, have a code base, do a substantial refactoring rewrite of large parts that takes you a week or 2 to get everything to like compile again, but then usually, in my case always so far, things just work, which is amazing. That's never happened like in the past for me before. And then moving to the second part, like the overlap between those things, again, for me as a learner, A, of Rust, B, of becoming a useful developer again in general. And you can, if you read about Rust on the internet, there's going to be a lot of complaining about the learning curve and the stupid borrowing checker and etc. etc. The point is, usually, if you really have to bash your head against the compiler wall because it's just refusing to do something, and the convolutions you have to do in the code to try to make it work, if that becomes too stupid,
you're thinking about the problem wrong.
Then there usually is a way to do things in a completely different style, which will A, make the code factor of 10 better, and it just works. And that is going towards the tooling side of Rust, the compiler and the linter, and like the format. Rust has a by default tool that does formatting. There's no wars about where the brackets are supposed to go, right? All these details are taken care of. Rust has a huge built-in quote-unquote ecosystem and management tooling for the ecosystem of crates, aka libraries, dependencies, manage license things, manage security, findings, etc. I'm not saying that this will catch everything all the time. That's also people doing this stuff, but all of that is built in. So like closing statement. But from my point of view, coming to this after decade of not doing anything much and before that doing things, Rust does feel like actually finally people learn from what we tried to do in the past 30 years and really actually try to do it right this time. I'm not saying that they're succeeding always, but there is an order of magnitude of difference between, in my experience so far, between those aspects when using Rust compared to anything else that I've looked at so far.
Yeah.
And that, you have to do it to believe it, I think.
Yeah.
But it's a thing.
We talk about open source communities a lot, and I think Rust is an example of an open source community where it's actually got actively engaged community, but also people that just are able to take in the input they get from their users and act on it, and actually then at the same time keep it coherent and keep it from breaking all the time. They pay a lot of attention to quality, but also it means that because it's a single place where the language specification is and all the tools are managed and the development of it is, they're actually able to do things like, for example, accept from Ferris Systems, who developed a certified version of the Rust compiler, which was certified to a high safety standard. They were then actually able to take that language specification and take it into the Rust Foundation. And now they can use that language specification to improve the language and to improve the way it's specified.
Just details, but the certified compiler is exactly the same as the upstream and regular one. The only thing that Ferris does is, well, they have created the first actual language stack to be able to certify it. And they're doing, the documentation paperwork for why it's certifiable. But it's exactly the same compiler that we get.
They do the
Certificate is essentially, here's the evidence.
And by the way, again, they've done this in a way where they essentially do an update release every quarter, and they could go like more often, but they automated the heck out of all that they're doing there as well, right? So
the language specification reflects that. They designed and built the way they do it with automated updates in mind. So a few other quick points. Rust, it's in the Linux kernel. It can be in the Linux kernel. There's been a certain amount of resistance to that, but you can read the statement from Greg about it. I think it's a really interesting statement. It's important to notice that actually the process of doing it has already uncovered bugs.
Yep.
And it opens up a potential for engaging a new generation of developers. I think this, Daniel's point here.
That's one of the points why I decided, hey, I'll give that a go. Once something is in the kernel, it will stay. Right? This is not a language that's going to be like gone in 3 years now. This is going to be there for pretty much ever. So
I think it's going to be here for a while. It's being adopted into another context as well. Talked about that. So it was designed with cybersecurity in mind, and that means that, okay, that's a slightly different field to safety, but some of the classes of issues that are relevant to safety are also known and managed as a result of this. And actually, it's more the process aspects of cybersecurity that differ, and the types of risks that they're considering. But many of the software aspects, how you manage that, how you actually manage those risks, are much the same. Reasons to choose over C for a new development. So this is the process we actually went through when we were thinking about how to write this safety monitor, which we created for Control OS. Considered using C, but actually it had some relative complexity in it, and that actually made it more sensible to use Rust because it enabled more junior developers who were really confident in Rust but didn't understand some of these kind of more arcane requirements to make use of existing libraries. We minimized the set of libraries we were using to make this more kind of something we could reason about and argue about, but it meant that we didn't need to supervise their every move. We just needed safety experts to kind of review what they were doing. And also a lot of the classes of error that you'd just be picking up all the time and see you just wouldn't compile. And that meant that we had a younger cohort of engineers who were prepared to engage with the challenge. This is something that I've heard at safety conferences. Please, can you make a next generation appear? Because we're all getting old and going to retire soon. If we don't get younger people interested in wrestling with these kinds of problems, then we're in trouble. And in the end, they're interesting engineering problems. If you present them to them as boring safety problems, then they're not. But if you say this is a really interesting engineering problem, this is the set of things we're trying to accomplish. They're like, wow, that's really cool. I never thought of even doing that. It's good. But also it means that long-term maintenance is easier because we're not having to police the kind of rules that would be running checkers on all the time. And this was something that was kind of coming from the Rust developers themselves. It actually reduces the cognitive load of the program because they're not having to think, oh, I can't use that feature of C because that would violate this. And so therefore, it means you're just focusing on the problem, not on how I need to police my language.
And also on getting people engaged. And going back to my story at the beginning, that sure, there will be exceptions, there's always exceptions, but a regular Rust project, you do a git clone and you do cargo build and it will run. There's no week to fix some stupid workspace.
And you can build tests into your documentation. You can literally have a test that's shown in the documentation and run it as part of your thing. It's so many of these things just work in a way that is astonishing. And then again, if you're kind of worried about moving to it from C, you can, as a Linux programmer on Linux, you can still use a lot of the binary oriented tools to do debugging because it's the same kind of context. So you can still use some of those familiar friends for debugging things once you actually get there. I think that was it.
Yeah, back on time almost.
Any questions?
I have some questions.
Please.
Is there a runtime library? Maybe.
Right to the point. Probably. There's one, but it hasn't been certified yet. It's a work in
Okay.
progress.
So yes and no is what I would say. It's not really a runtime library. It's not an interpreted language. There is there are libraries that you end up,
There's some libraries.
but they get built into the thing. So that doesn't mean you can end up with quite large binaries, which is one of the motivations for us kind of keeping the set of libraries we included small. We didn't want a huge binary. But I think the point about it is it's actually a very flexible language at lots of different levels. They haven't only thought about it at the language level, they've thought at it about the build level, about the integration level, they've thought it at all the levels that you will eventually have to wrestle with as a software engineer.
So there's a core library as usual, which also is right now in the process of being certified by Ferris. I don't have an ETA, but they're working through that. It's a compiled language, no runtime things. There is async functionality, etc. in runners for those, and there's options there and variety, and most of these options are not suitable for bare metal low level embedded use cases. But again, there is then options in the ecosystem and in the compiler, etc., to build code for very low level core hardcore embedded systems. So that's
this is very much an option for very low level.
Yeah.
But if it's an option for low level that disables Rust features, then how different it is from C?
Again, it's about how you want to think about the problem.
I'm thinking about that. I have a constraint switching to Rust, which is advertised because of integrity features, fine. But then you're telling me that if I want to use it in a constrained environment, I have to switch them off. So that I'm left to
in a constrained environment, you might not use async, but that's your decision. You find a small, fitting async library right your own, you can do that. You're not going to use the standard bit. So you do.
The constraints are about the set of libraries that you're able to use, not the core language features. The core language features, they're baked in.
Stuff like panic still remains as a runtime.
That's beyond my level of competence.
What was the question?
I asked if I want to have a small footprint, do I still retain the runtime panic feature?
Yeah. There are you can relatively easily also provide your own panic handler to whatever processing you need.
But on bare metal embedded, you wouldn't have
panic, you would have to implement your own panic because you would be using the non-CD.
Yeah, but there are ready-made, HTTP panic handlers that you.
Yeah, like-
Use instead.
My question was more in general, how much do I get back to a sort of C scenario if I start?
You don't, you will get the full features of the language, so you get the borrow checker will be there. I mean, everything that you are used to, you will not have some goodies, but
But you have also, there's a library called Heapless, for example, that gives you all the data structures, high-level data structures like vectors, maps, and all that, what are backed by the stack or by a block memory that you statically allocate. So you can get those kind of rich abstractions as well on a bare metal system. So it's a much.
and you get extras. I mean, the biggest selling point of Rust, we don't sell it a lot, is the ecosystem. You get carb audit to ensure that everything that you pull in, any dependency you pull in, don't have any CVs, any non-CVs. You have Clippy, everything comes baked in your development environment. So it's so lovely. You don't need the covariate, the polyspace, whatever external tool to make sure that your code.
And if you're worried about controlling the internet, you can still do what we do and mirror all your inputs and just say, actually, I've identified all the things that go into my Rust library. I'm going to control them because I'm paranoid.
You just have to archive your target folder.
Well, yeah, there's, what I mean, what I'm saying is that because of the way it's designed, you can solve these engineering problems.
Maybe we should say about some limitations, because it's very positive. There are some problems in general in Rust, so Carbo build always builds from source, so you have a big project. There is some, you could say some sustainability problems. I mean, it would be great if we had some sort of binary class. Then there are packages that could pull something that is vulnerable, but Carbo will detect that. But if you don't run Carbo, you could end up with pulling 3 different versions of an array library, for example, one of which is vulnerable. And so there are such problems that are very nuanced compared to C, where you will have a little bit more surface for somebody to play with.
The language is, it does take some time to get your head around it, but actually it's, having done it, it was really refreshing because it made me think about the problems in a slightly different way. I started out fighting it and saying, why won't you let me compile? And then when I eventually kind of stepped back and said, okay, if I break the problem down in a different way, actually, this makes more sense. I think that's true of you learning any language, but it was particularly satisfying in Rust to kind of go on that journey and get to the end and think, actually, this helped me to think about programming problems in a different way, and I found that refreshing.
And the compiler is actually really trying to give you helpful error messages.
Yes, you will spend a lot of time fighting the compiler, but the error messages are actually useful.
Yeah.
Which isn't always the case. Please.
Another question, yeah, so you mentioned about the static code checking, normally static code checking is if you want to get a spice assessment or TIF assessment, we have to show that. Is there any experience, have you talked to any assessors, and unfortunately, I think our assessor is not here, but, would they just accept Rust based on what you said a priori, or? Is that...
I don't know, but as I say, we did the investigation with Exeter, they
Yeah,
wanted to understand it, so.
As an assessor, the standards never mention Misra as a requirement. They never, and if you look at the raw basics in IC 61508, there they say you need to take care of the issues of your programming language.
Yes.
That's all it says. You need to choose a good language for you, and you need to take care of the issues. That's it. And it's not like, oh, I can't do Misra checks on Rust, that's why I can't use Rust.
There are only specific rules that are enforced in table 6, I think.
There's a lot of things in 61508. Well, a couple of my colleagues are in the process of writing a document about it, breaking it down and saying, how does Rust satisfy each of these criteria?
Yeah, exactly, but
But it's all there. So
That's, yeah, the standards don't say you see with Misra, they say take care of things.
they say,
They want good code and
Yeah.
Misra is a tool, but it is not the only solution.
Misra is a response to, we want to use C. And we could, they weren't allowed to use C, but define a limited subset and you can.
Yeah.
What we're saying with Rust is you don't need to do that.
Which was the response to, we don't want to pay license fees for ADA.
Okay, so at the end of the day, it looks pretty good that an assessor would accept Rust.
There's strong evidence, if they're gonna fight you, then
I guess. it's
Change assessor.
And just whoever is interested, but a couple of months ago, 1 or 2 or 3-ish, the Rust project, I always confuse the two, but there's safety, Rust safety or Rust in safety context use cases. Working group for some time now. It's open source, etc. Anybody is interested, very welcome, obviously, and it's going to be, defining, let's say, coding guidelines, find things that a bit more guidance might be useful, and ideally, anything where that's possible, that will end up in additional linter rules, etc. So it becomes part of the tool ecosystem.
Could
But
you
that's-
share the
Yeah, sure,
details?
I'm interested too.
I have to find them first.
Well,
Yes,
if you could share with us
no,
about this.
no worries, don't worry.
And this is a great closing word for the session, I guess. We just maybe take a bio break of 5 minutes and then.
Just, it's called the Rust Safety Critical Consortium, I believe, but I'll find a link and then.
I'll put it in my slides. Yeah.
I guess we stop the recording for the session.